Okay, so now we're ready to integrate our partial fractions. So hopefully you've spent some time making sure that you know how to do the partial fraction decomposition, and you've gone through that worksheet and practiced those problems, and you know for sure that you can break those up, because this part of the video I'm not going to spend the time doing that part of the problem again. All right, we're only going to do the integrating part. So we're going to do integration of rational functions by partial fractions, which we know how to do. So now we're going to focus on the integration part. And we're only doing non-repeated linear factors, so that makes the integration really easy. Okay, the one thing you need to watch out for, before you do partial fraction decomposition, you have to make sure the degree of the denominator is more than the degree of the numerator. So the denominator has to have a higher power than your numerator. Then you're going to use the partial fractions and integrate. So if your numerator is ever a higher power or equal to the denominator, then you're going to have to use long division. And that's what I'm going to do some of in this video. Okay, so we have already done the decomposition of x plus 5 over x squared plus x minus 2. It turns out to be these two partial fractions. So all we need to do is integrate these now. And we talked about, as long as these are nice linear functions and have a 1 as a coefficient is helpful too. Then the antiderivative of each of these is just a ln. So this is 2 natural log of x minus 1, minus 1 times the natural log of x plus 2, and then plus c, that's my answer. So once you've done the work of the decomposition, then doing the antiderivatives is pretty easy. Okay, there's just one little catch you got to make sure of on the coefficients. Now this one is an example of the the denominator is not bigger than the numerator. In this case, our numerator is larger. So this is a situation where you have to do long division. So we're going to take x cubed plus x, and we're going to divide it by x minus 1. Okay, so to do that, x goes into x cubed x squared times. So that's x cubed, you just multiply now, x cubed minus x squared. And when you do long division, you subtract, so that's going to make this addition. So x cubed minus x cubed goes away, and then this is going to be x plus x squared. So x plus x squared. Now x goes into x squared x times. Now multiply x by both of those, so x squared minus x. We're going to subtract, so that's going to change this into a plus sign. So x squared minus x squared goes away. X plus x is 2x, and now we're going to go again. X goes into 2x, 2 times. Now multiply both of these by 2, gives you a 2x minus 2, and you're going to subtract, which ends up making you add this number. So those cancel, and you're left with 2. X doesn't go into 2, so that's our remainder. So we have 2 divided by our divisor, and so there's our answer. So this is the quotient answer of our division. So what you're going to do is replace this problem with the long division's quotient. So this is x squared plus x plus 2 divided by x minus 1 dx. So I've just replaced the original problem with the quotient answer using the remainder as the remainder divided by the divisor. Replace that function with that answer. So now we're going to do the antiderivative of this, which you know how to do. It's easy. The antiderivative of x squared is x cubed over 3. The antiderivative of x is x squared over 2. Antiderivative of 2 is 2x. And then this one, since we have a 1 here in the front, this is an ln, a real easy ln problem. It's 2 times the natural log of x minus 1. Then plus c, there's my answer. Whoops. So here's our answer. So if the numerator has a higher power or equal to even the denominator's power, then you have to do long division. Now this problem, we did the partial decomposition on the previous video. So I'm just going to put that answer in here. So when we did the ABC, we factored this, and we had 3 parts, and we found an A, B, and a C. our answer we got was 1/2 over x plus 1/5 over 2x minus 1. And we got to be careful about him. And then C was negative 1/10. Negative 1/10 over x plus 2. So when you do your partial fraction decomposition, that's where you factor your denominator and then you put your ABCs, and this ends up having 3 parts, and then you do all the algebra. And this is our answer we ended up with, and you should have already watched that previous video. So this is the answer we got. So now we're ready to just integrate it. So here, this is just a straight up ln. So this is 1/2 ln of x. Now for this one, we got to watch out for this one because it is ln still. It's a ln of 2x minus 1. But the issue is, what is the derivative of 2x minus 1? The derivative of 2x minus 1 is a 2. And we don't have a 2 up here in the numerator. So because we don't have a 2, we have to divide by 2. So that's going to make this a 1/10 here. Because we have to divide by 2. Because we don't have our extra 2. I could put the extra 2 up there, but then I'd have to put this 1/2 out here to counteract it, and that's where the 1/10 is coming from. So this part is the ln of 2x minus 1, but then my coefficient is 1/10. So if you ever have a coefficient in front of your x in the denominator, divide by whatever that number is to get your correct antiderivative. And then this is going to be a minus 1/10. This has a 1 in front of it, so I'm good there. And then it's x plus 2. And then plus c, and there's my answer. And we'll have a few more that have, we'll have a few more here as we go down doing some more problems. We'll have a few more that have coefficients in front of our linear factors. All right. So you're doing the partial fraction decomposition, and then once you do that, then your antiderivatives are pretty easy. They're ln's. Just be careful when we have coefficients, and we'll do some more of those here as we go. This one, we did not do this one in the previous video, and notice the denominator's power is not higher than the numerator's power. It is equal. So this is another one where you're going to have to divide. So 3t minus 2 divided by t plus 1. So t goes into 3t 3 times. So then you multiply by 3, 3t plus 3. And then you subtract, right? So that's canceling. And then negative 2 minus 3 is negative 5. So that's negative 5. And then t doesn't go into negative 5, so that's going to be my remainder, negative 5 divided by my divisor. So this is my quotient answer. So I'm going to replace this rational expression with my quotient answer. So this is 3 plus negative 5 over t plus 1 dt. And now I'm just doing the antiderivative. So the antiderivative of 3 in terms of t's is a 3t. And this is an ln. I have a 1 coefficient, so it's an easy one. So that's going to be negative 5 ln of t plus 1, and then plus c, and we're done. So the only new thing I'm adding in here is sometimes you have to divide if your numerator and your denominator, if the numerator's power is equal or more than the denominator's power, you have to do long division. We want the denominator's power to be more. So when the denominator's power is more, that's when you do your decomposition. Now, this one was not one of the ones that we did the decomposition of earlier, so I'm just going to go through this one step by step. Oh, and I forgot to change this. This should be a y right there. All right, so we're doing the integral in terms of y, so that needed to be a dy. So our problem is this, y plus 4, 2y minus 1. So we are going to write this as my pen is freaking out on me, a over one of the linear factors plus b over the other linear factor. And then remember, you're multiplying this by the common denominator, y plus 4 and 2y minus 1. So you're multiplying that across the whole thing. So we end up with just y. And remember, the shortcut is a ends up getting multiplied by this denominator. So it's a times 2y minus 1 plus b, and he gets multiplied by this denominator over here. So now you do your choices. You choose specific values of y that will get rid of each letter. So to get rid of the a, I would choose y to be a half. So now go in and fill in a half for each of those. So y would be a half equals, and then if I put a half here, that's going to make that be 0. So a would go away. Putting a half in here, that'll be 4.5, which is 9 halves. So that would be 9 halves b. Now to get rid of 9 halves, multiply by the reciprocal. 2's will cancel. So b is going to be 1/9. So 1/9 goes there. Now pick another specific value of y to get rid of the b this time. So in order to get rid of b, y would have to be -4. So now let's plug a -4 into these guys. So y would be -4. And then -4 here is going to be -8 minus 1 is -9a. And then you divide both sides by -9 and you get 4/9. So that's your a. So your a is 4/9. So the problem we have at this point is we are replacing this factored problem with the partial fractions. So my integral is now going to be 4/9 over y plus 4. And then plus 1/9 over 2y minus 1. And that's the one we got to be careful of because he has a coefficient. And then that'll be dy because we were in terms of y, so this problem needed to have a dy on it. All right, so now we're integrating this. So the first one is easy to integrate because the derivative of y plus 4 is just 1. So that's going to be 4/9 times the ln of y plus 4. On this one, the derivative of 2y minus 1, the derivative of that is 2. So we would need to have a 2 up here, which means there needs to be a 1/2. So my coefficient is going to be 1/18, and then I would have the ln of 2y minus 1. And then that'd be plus c. And I believe we're good there. That is our final answer. Yep, we're done. We didn't have to do any limits of integration because some of these have limits of integration on the problem where we got to do fundamental theorem. But this was not one of those. All right, so that's our answer on that one. All right, next problemo, number 6. Oh, that's one that has limits of integration. Now, this one, I believe we already did. I'm pretty sure we did this one already. So this one, the decomposition for this ended up being 2 over x minus 2. And then we had -1 over x minus 3. So there's our decomposition. It's still 0 to 1. That does not change. So we've done all of our math. We did that in the previous video that you watched where we did our partial decomposition. So this rational expression breaks up into these two. So now we do our antiderivatives. These are both have coefficients of 1, so these are straightforward, easier natural log problems. So this is 2 natural log of x minus 2, and then minus 1 natural log of x minus 3. I don't need the plus c because we're evaluating from 0 to 1. So now we get to do the fundamental theorem of calculus. Okay, so I'm going to plug a 1 in. So this will be 2 natural log. If you put a 1 in here, 1 minus 2 is a -1, and then the absolute value of that is going to be a 1. Minus ln of putting a 1 in here. 1 minus 3 is -2. Absolute value of -2 is 2. Then you're going to put a 0 in there for the second half. So this will be 2 natural log. Put a 0 in here, will be -2. Absolute value is 2. Minus the natural log of, put a 0 in here, is -3. The absolute value -3 is 3. So then this is going to be our final answer here. Now, ln of 1, that's 0. The natural log of 1 is 0, so he goes away. And so then we're going to have a negative natural log of 2 minus 2 natural logs of 2. So that's going to be minus 3 natural log of 2's. And then minus ln of 3. And if you wanted to do it on a calculator, you could, but we don't have to. We could just leave that. Just leave that as our answer. We don't have to simplify that anymore. All right. This one I don't believe we did on the previous problem, but notice our denominator's power is not higher than the numerator's power. So we're going to have to do long division. So I'm going to have to divide x cubed minus 4x minus 10. I got to divide that by x squared minus x minus 6. So x squared goes into x cubed x times. So then I multiply through by x will be x cubed minus x squared minus 6x. And then you subtract. So we subtract. We got to change all of our signs. So x cubed minus x cubed goes away. And then we've got an x squared, and we've got negative 4x plus 6x will be 2x's, and then minus 10. All right? So now we go again. X squared into x squared goes one time. So now multiply through by 1. We have x squared minus x minus 6. So now we're going to subtract, and that changes everybody's signs. So then that goes away. 2x and x is 3x, and then negative 10 plus 6 is negative 4. X squared does not go into 3x, so we have to write this as a remainder of 3x minus 4 over x squared minus x minus 6. All right? So we have to do that. So now look at what we got. We now have the integral from 0 to 1 of x plus 1 plus 3x minus 4 over x squared minus x minus 6 dx. So all I did was I replaced my original problem with the quotient of my long division process that I did. All right, so now the issue with that, though, then, is the fact that this part right here, my denominator's power is larger than my numerator's power. So I have to do the decomposition of this part. So I'm going to scoot down here and do the decomposition of that. So that's 3x minus 4 over x squared minus x minus 6. Let's factor this denominator. So to get a 1 in the middle, I need to use 2 and 3, and I need to use a minus and a plus. So I'm going to break this up into a over x plus 2. And then b over x minus 3. And so now I'm going to get rid of all the denominator stuff by multiplying by the common denominator. So remember that leaves me with the numerator equal to the a times this denominator plus the b times that denominator. Now here's where we get to choose specific values of x to help us out. So I'm going to get rid of the a. I'm going to choose x to be 3. So if I choose x to be 3, I'm plugging in 3's everywhere. So if I put a 3 here, that'll be 9 minus 4, that'll be 5. Putting a 3 in here, the a's gone. Putting a 3 in here, that'll give us 5b. So when you divide by 5, b is 1. So b is a 1 right here. And so now the next one we've got is I get to choose to get rid of the b's. So I'm going to choose x to be negative 2. So now I'm going to plug negative 2 in for everybody. So putting a negative 2 in here is going to make negative 10 equals. Put a negative 2 in here is going to make negative 5a. And then, of course, negative 2 here makes the b go away. So now if I divide by negative 5, a is going to be 2. So a is 2 here. So now when I go back up to this problem, I can replace this rational expression with these two partial fractions. So now I have this going on, x plus 1 plus, in place of these guys, I'm going to put 2 over x plus 2 plus 1 over x minus 3, and then dx. So now I can do my antiderivatives like really, really easy. So the antiderivative of x is going to be x squared over 2 plus the antiderivative of 1 is just going to be x plus, now here this is one where this has a 1 in front of it, so this is going to be a straightforward ln, and this is my coefficient, so 2 natural log of x plus 2. This has a 1 in front of it, and that's a 1 on top, so that's going to be a straight ln of the absolute value of x minus 3. I don't need the plus c because we're evaluating from 0 to 1. Now I'm ready to do my fundamental theorem of calculus. So fundamental theorem of calculus. So I'm going to put a 1 in first. So putting a 1 in here will make that 1/2 plus 1. Putting a 1 in here is going to make 2 ln of 3. And then putting a 1 in here is going to be ln of the absolute value of -2, which is 2. Then putting a 0 in, everybody, that'll make that 0, that'll make that 0. This will be 2 ln of, putting in a 0 will make that 2. And then plus, putting in a 0 here will make that ln of the absolute value of -3, which will be 3. So now I just simplify my math here. What do I got? I got 1/2, so that's 3/2. Plus, let's see, 2 ln of 3 minus an ln of 3 will be just a ln of 3. And this is a ln of 2 minus 2 ln of 2, so that'll be a minus ln of 2. So this is my final answer. And I simplified it down as far as I could. Alrighty, so there we roll. I believe this is the last one. And let's see, I can't remember if we did this one or not. I think we did. I think we did this problem. Yeah, we did. So this one ended up being 3 parts when we did the decomposition of it. And we ended up with 1 over x, -1 over x plus 1, and 1 over, got that straight mark, 1 over x minus 1. All right, so we do the decomposition of this by factoring the denominator and then setting it up with the 3 parts, because this ends up having 3 linear factors, a, b, and c. We did all the algebra and found these a, b, and c values. So now the antiderivatives, these all have coefficients of 1, so these are all straight up ln problems. So this is ln of x, of the absolute value of x. This is minus the natural log of x plus 1. And this is plus the natural log of x minus 1. And since this doesn't have any limits of integration, it's a plus c problem, and there's our answer. Now, there are other algebra things that you can do with these, but because you can put ln's together, when you're adding, they multiply, and when you subtract, they're division. So you can combine these things together, but we're not going to spend the time to do that. So your assignment, you have some book work to do. I tried to pick out only specific problems, not doing a whole bunch of real heavy problems. So on page 492, it's 7 to 17 odd, just the odd problems, and you're also skipping 15. So that's not going to be very, very many problems at all. So practice doing the decomposition and then integrating and everything. So just make sure you can do, because this can be, it's not hard, but it's multi-stepped, especially if you got to divide, then you got to do the decomposition, and then you got to do the integration, and then you got to do the fundamental theorem. It can be pretty long, but just time consuming. So I try not to give very many problems. So just make sure that you work through those and can do each of those problemos.